GCE O Level Mathematics, Lecture 2, Factors and Multiples. Hello everyone, my name is Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Before we want to start the lesson, let's discuss about what are we going to learn in this video. First, we will learn how to recognize prime numbers. Then, we will learn how to express a composite number as a product of prime factors, followed by represent the prime factorization of a number in index notation. Next, we want to find the highest common factor or HCF and lowest common multiple or LCM of a group of numbers by using prime factorization. Finally, we want to solve problems involving HCF and LCM. Factors. We know that 0, 1, 2, 3, and so on are whole numbers. We use whole numbers to count things. A whole number greater than 1 can be expressed as a product of two whole numbers. Let's look at this example. The number 20 can be expressed as products of two numbers as follows. 20 equals 1 times 20. 20 also equals 2 times 10. 20 also equals 4 times 5. From here, the factors of 20 are 1, 2, 3, 5, 10, and 20. 20 is divisible by each of its factors. Now, let's look at this question. Find the factors of 72. Here is the solution. 72 equals 1 times 72. 72 equals 2 times 36. 72 equals 3 times 24. 72 also equals 4 times 18. 72 equals 6 times 12. And 72 equals 8 times 9. Hence, the factors of 72 are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. You can try this example yourself. Find the factors of 105. Here is the solution. 105 equals 1 times 105. 105 equals 3 times 35. 105 equals 5 times 21. 105 equals 7 times 15. Hence, the factors of 105 are 1, 3, 5, 7, 15, 21, 35, and 105. Multiples and prime numbers. What is multiples? When a number is multiplied by a non-zero whole number, a multiple of the number is produced. Here is an example. 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. 3 times 4 equals 12. And 3 times 5 equals 15. From here, the multiples of 3 are 3, 6, 9, 12, and 15. What is prime numbers? A number is considered as a prime number when it is a whole number, it is greater than 1, and it has only two factors, 1 and itself. The first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Here's a question. Why 0 and 1 are not prime numbers? Notice that 0 and 1 are not in the list of the first 10 prime numbers. The answer is, for 0, it is not greater than 1. Also, 0 has only one factor, which is itself. For 1, it has only one factor, which is 1. Hence, 0 and 1 are not prime numbers. Next, composite numbers. What is composite numbers? A composite number is a whole number greater than 1 that has more than 2 factors. For example, the number 4 has 3 factors, which are 1, 2, and 4. Hence, 4 is called a composite number. Here's a question. Can a whole number be both a prime number and a composite number? The answer is no, because prime number and composite number are opposite to each other. A whole number cannot be both a prime number and a composite number. 0 and 1 are neither prime number nor composite numbers. Let's look at this example. State and explain whether 851 and 113 are prime numbers. Here is the solution. The thinking process is, if a number is divisible by prime numbers smaller than itself, then it is not a prime number. Therefore, 851 divided by 23, we get 37. 851 is divisible by 23, hence 851 is not a prime number. However, 113 is not divisible by any prime number smaller than itself. Therefore, 851 is a prime number. Now, you can try this yourself. State and explain whether 127 and 473 are prime numbers. Here is the solution. For 127, it is not divisible by any prime number smaller than itself. Therefore, 127 is a prime number. On the other hand, 473 divided by 11, we get 43. Therefore, 473 is divisible by 11. Hence, 473 is not a prime number. Prime factorization. What are prime factors? If a prime number is a factor of a composite number, it is a prime factor of the composite number. Here is an example. 42 equals 2 times 3 times 7. 42 is a composite number, and 2, 3, and 7 are prime factors of 42. Let's look at this example. Find the prime factorization of the following numbers. A. 1020 and B. 3135. Here is the solution. In order to get the prime factors, we should divide the number continuously with prime numbers. For A, 1020, we start with the lowest prime number, which is 2. We divide 1020 with 2, we get 510. 510 can still be divided by 2, hence we will continue to divide and we get 255. And now 255 is not divisible by 2. We move on to the next prime number, which is 3. So 255 Divide by 3, we get 85. For 85, it is not divisible by 3. We move on to the next prime number, which is 5. 85 divided by 5, we get 17. So 17 cannot be divided by 5. We'll continue to find the next divisible prime number, which is 17, and we get 1. So we multiply all these prime numbers, which is the product prime factors of 1020 equals 2 times 2 times 3 times 7 times 5 times 17. We do the similar steps for the B, 3135. So 3135 is not divisible by 2, so we move on to the next prime number, which is 3. So 3135 divided by 3, we get 1045. So 1045 is not divisible by 3. Then we move on to the next prime number, which is 5. So 1045 divided by 5, we get 209. 209 is not divisible by 5. Hence, we move on to the next prime number, which is 11. 2009 divided by 11, we get 19. And move on, 19 divided by the next prime number, which is 19, and eventually we get 1. Hence, 3135 equals 3 times 5 times 11 times 19. Now, you can try this number. C, 2730. You can pause the video and try to do it yourself. Here is the solution. 2730. It is divisible by the lowest prime number, which is 2, and we get 1365. So 1365, the next prime number will be 3. So we divide 1365 by 3, we get 455. So 455 is divisible by 5. Therefore, we get 91. And 91 is divisible by 7. We get 13. 13 is divisible by 13. And eventually, the last number is 1. Therefore, 2730 equals 2 times 3 times 5 times 7 times 13. Index notation. When a number is multiplied by itself more than once, we use index notation to represent it. For example, 3 times 3 equals 3 squared. We read it as 3 squared or 3 to the power of 2. 3 times 3 times 3 equals 3 cubed. We read it as 3 cubed or 3 to the power of 3. 3 times 3 times 3 times 3 equals 3 to the power of 4. We read it as 3 to the power of 4. Let's look at this example. Find the prime factorization of the following numbers expressed in index notation. A, 702. B, 792. Here is the solution. For A, 702, we do the same thing. We start with divide 702 with the lowest prime number, which is 2, and we get 351. So 351 is not divisible by 2. We move on to the next prime number, which is 3. So 351 divided by 3, we get 117. So 117 is divisible by 3, we get 39. And 39 is divisible by 3, we get 13. And now 13 is not divisible by 3, we move on to the next divisible prime number, which is 13, and we get 1. Therefore, 702 equals 2 times 3 squared times 13. Now, you can try this number yourself. 792. Alright, here's the solution. 792. We start with the lowest prime number. So 792 divided by 2, we get 336. So 336 is an even number. It is divisible by 2. We get 198. 198 is an even number. We still can divide by 2. We get 99. 99 not an even number. So we move on to the next prime number, which is 3. So 99 divided by 3, we get 11. So 11 is not divisible by 3, but we move on to next divisible prime number, which is 11. And finally, we get the last digit as 1. Therefore, 792 equals 2 cubed times 3 times 11. Do you get the answer correctly? Highest common factors. The highest common factor, or HCF, of 2 or more positive whole numbers is the largest positive integer that divides the numbers without a remainder. For example, factors of 18 are 1, 2, 3, 6, 9, and 18. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. From here, we compare the factors of 18 and 24. We find that the common factors of 18 and 24 are 1, 2, 3, 6. Hence, the highest common factor, HCF, of 18 and 24 is 6. Let's look at this example. Find the HCF of 225 and 750. Here is a solution. There are two methods to find the HCF of these two numbers. The method 1 is prime factorization method. First, we write down the prime factorization of 225, which is 3 squared times 5 squared. Then, we write the prime factorization of 750, which is 2 times 3 times 5 cubed. Now, to write down the HCF of these two numbers, if we find they have common body, we choose with the lowest power. So for HCF of 225 and 750, it is 3 times 5 squared. Notice that only 3 and 5 are the common bodies, while 2 is uncommon. Therefore, 2 is excluded. For the body of 3, we'll take the lowest power, which is 3, then we write here 3. For 5, the lowest power is 2, then it is 5 squared. And we calculate the HCF equals 75. The second method is called short division method. First, we write down the two numbers together like this, and we start to divide with the prime numbers. We start with 3, so both numbers are divisible by 3, and we get 75 and 250. We continue with the next prime number, which is 5. So 75 divided by 5, we get 15. 250 divided by 5, we get 50. And these two numbers is divisible by 5. We continue with 5. We get 3 and 10. And now, 3 and 10, there is no common prime numbers that can divide both numbers. So no more common divisor. Therefore, the HCF of 225 and 750 is 3 times 5 squared, which gives us 75. Now, you can try this example yourself. Find the HCF of 252 and 360. I encourage you to try both methods so that you can learn both methods. You can pause the video and try to do it yourself. Here is the solution. For the first method, we write down the prime factorization of 252, which is 2 squared times 3 squared times 7. And 360 equals 2 cubed times 3 squared times 5. And from here, when they have common body of 2, we choose the lowest power, which is 2 squared. For the 3, both have the same power, then it is just 3 squared. 7 and 5 are not common body, therefore we don't include them. Hence, HCF equals 2 squared times 3 squared, which gives us 36. Let's try method number 2. We write down both numbers together like this. Then we start to divide by the lowest prime number, which is 2. We get 126 and 180. So these two numbers are even number, hence they are divisible by 2. We get 63 and 90. And now, 63 is not divisible by 2. Therefore, we move on to the next prime number, which is 3. So 63 divided by 3, we get 21. 90 divided by 3, we get 30. 21 and 30 are divisible by 3. Therefore, we divide by 3 and we get 7 and 10. And now, 7 and 10, there is no common divisor. Therefore, HCF equals 2 squared times 3 squared. Which gives us 36. What about finding HCF for more than 2 numbers? Let's look at this example. Find the HCF of 84, 126, and 245. Here is the solution. We can apply both methods to find the HCF of 3 numbers. For method 1, 84 equals 2 squared times 3 times 7. 126 equals 2 times 3 squared times 7. And 245 equals 5 times 7 squared. From here, we find that 2 and 3 are common bodies for 84 and 126, but not common for 245. Therefore, we don't include 2 and 3. 5 only appears in 245, therefore we also don't include 5. Only 7 is common for all the 3 numbers, and the lowest power for 7 is 1, therefore the HCF for this case equals 7. We can also use method 2 to find the HCF of these 3 numbers. First, we write these 3 numbers like this, and these 3 numbers only has one common divisor, which is 7. We get 12, 18, and 35. There is no more common divisor for 12, 18, and 35. Therefore, the HCF for 84, 126, and 245 is 7. Now, you can try this example yourself. Find the HCF of 154, 330, and 396. You can pause the video and try to find it yourself. Here is the solution. For method 1, 154 equals 2 times 7 times 11. 330 equals 2 times 3 times 5 times 11. 396 equals 2 squared times 3 squared times 11. From here, only 2 and 11 are common bodies. Therefore, for HCF, 2 we choose the lowest power, which is 2, and same for 11. Then the HCF is 2 times 11, which gives us 22. For method 2, we write down the 3 numbers together, and since these 3 numbers are even number, they are divisible by 2, we get 77, 165, and 198. These 3 numbers, they are divisible by 11, and we get 7, 15, and 18. And now 7, 15, and 18 has no more common divisor, Therefore, the HCF of 154, 330, and 396 equals 2 times 11, which gives us 22. Now, let's solve word problems related to highest common factors. Here's an example. A rectangular field of 20 meters by 15 meters is divided into identical square plots of land. Find the largest possible length of a side of each square plot of land. Here's the solution. The length of a side of each square plot of land should divide 20 and 15 respectively. To find the largest possible length of the square, we need to find the HCF of 20 and 15. 20 equals 2 square times 5, and 15 equals 3 times 5. Therefore, the HCF of 20 and 15 is 5. To illustrate, let's look at this diagram. This is the plot of the land with the length of 20 meters and the width of 50 meters. And it can be divided into identical squares with the side of 5 meters. Hence, the largest possible length of a side of each square plot of land is 5 meters. Now, let's try this example yourself. A rectangular piece of paper of 35 cm by 28 cm is cut to obtain identical squares. Find the largest possible length of a side of each figure. You can pause the video and try to solve it yourself. Here's the solution. To find the identical squares, we have to find the HCF of 35 and 28. So let's try the method 1. 35 equals 5 times 7 and 28 equals 2 square times 7. Therefore, the HCF is 7. Or you can also try with method 2. 35 and 28 divided by 7, we get 5 and 4. And the 5 and 4 has no more common divisor, therefore the HCF is 7. Hence, the largest possible length of a side of each figure or square is 7 cm. Lowest common multiples. The lowest common multiples, or LCM, of two or more whole numbers is the smallest common multiple of the numbers. Let's look at the multiples of 6, which are 6, 12, 18, 24, 30, 36, 40, 48, 54, 60, and so on. For multiples of 8, they are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and so on. By comparing the multiples of 6 and 8, we can find the common multiples of 6 and 8, which are 24, 48, and so on. The LCM of 6 and 8 is 24. Common multiples of 6 and 8 can be more than 2, but there is only one LCM. Now let's look at this example. Find the LCM of 24 and 90. Here's the solution. And again, there are two methods to find the LCM. The first method is prime factorization method. So 24 equals 2 cubed times 3 and 90 equals 2 times 3 squared times 5. So to find the LCM, here's a tip. If there is common body, we'll choose with the highest power, and if there is uncommon body, we'll still take it in. Therefore, the LCM of 24 and 90, the common bodies are 2 and 3, So for 2, we choose the highest power, which is 2 cubed. And for 3, we choose the highest power, which is 3 square. And 5 is the uncommon body, we will still consider it. Therefore, the LCM of 24 and 90 is 2 cubed times 3 square times 5, which gives us 360. We also can use the second method, which is the short division method. So the idea is we will write both numbers together and we will divide them with the prime numbers. Start with the lowest prime numbers. For this case, these two numbers are even number. We start with 2 and we get 12 and 45. 12 and 45 can be divided by 3. We get 4 and 15. And now 4 and 15, there is no common divisor, but we can start to divide separately. For 4, you can divide by 2, we get 2. 15 is not divisible by 2, we will still copy. 2 can be divided by 2 again, then we get 1. And again, 15 is not divisible by 2, we will still copy. Next, 15 is divisible by 3, you get 5. And 5 is divisible by 5, we get 1. Therefore, make sure that at the end, both numbers becomes 1. Alright, and now, the LCM for 24 and 90 is 2 cubed times 3 square times 5, which gives us 360. Now, let's try this example yourself. Find the LCM of 40 and 150. I recommend you to try both methods. You can pause the video and try to find yourself. Here's the solution. For method 1, 40 equals 2 cubed times 5. 150 equals 2 times 3 times 5 square. So from here, 2 and 5 are the common bodies and 3 is the uncommon body. For 2, we choose the highest power, which is 2 cubed. For 3, we'll consider in, so we copy down the 3. And for 5, the highest power is 5 square. Therefore, LCM is 2 cubed times 3 times 5 square, which gives us 600. For method number 2, we write both numbers together, 40 and 150. So we start with the smallest prime number, which is 2. So 40 divided by 2, we get 20. 150 divided by 2, we get 75. And from here, both numbers is divisible by 5, we get 4 and 15. 4 and 15, they don't have common divisor, therefore we start with the 2 here. To divide by 4, we get 2 and 15. And we continue to divide by 2, we get 2 divided by 2 is 1, 15 we still copy. And now 15 divided by 3, we get 5. So 5 divided by 5, we get 1. So at the end, the both numbers is 1. Therefore, the LCM is 2 cubed times 3 times 5 square, which gives us 600. Now let's look at this example. Find the LCM of 26 and 99. Here's the solution. So 26 equals 2 times 13 and 99 equals 3 square times 11. And you can see that in this example, these two numbers don't have common bodies. Therefore, the LCM, we have considered all the bodies, and if there's a power, we will choose the power as well. So the LCM will be 2 times 3 square times 11 times 13, which gives us 2,574. Take note that when two numbers are relatively prime, they have no common factors greater than 1. The LCM is the product of the two numbers as in the above example, which is 26 times 99, which gives us 2,574. Alright, now you can try this example yourself. Find the LCM of 34 and 57. You can pause the video and try to solve it yourself. Alright, here's the solution. So 34 equals 2 times 17. 57 equals 3 times 19. And again, in this example, you see that there is no common body. Therefore, the LCM will consider all the bodies, which gives us 2 times 3 times 17 times 19, and we get 1938. Now, let's try to find the LCM of three numbers. Here's an example. Find the LCM of 20, 24, and 70. So here's the solution. We can use both methods to find. For method 1, 20 equals 2 squared times 5. 24 equals 2 cubed times 3. And 70 equals 2 times 5 times 7. From here, the 2 is the common body. 3, 5, and 7 are uncommon body. So the LCM will be 2 cubed times 3 times 5 times 7, which gives us 840. We can also use method 2 to find the LCM, which is 20, 24, and 70. They are divisible by 2. We get 10, 12, 35. So these three numbers don't have common divisor, so we just try to divide by 2 first. For 10 divided by 2, we get 5. 12 divided by 2, we get 6. 35 is not divisible by 2, so we will just copy down the value. And now, these three numbers don't have any common divisor. We start with the lowest prime number, which is 2. So 6 divided by 2, we get 3. The rest, we just copy down the value. Then continue with 3, which is 3 divided by 3, we get 1. So 5 and 35, we just copy down the value. And now we can start to divide by 5. So 5 divided by 5, we get 1. 35 divided by 5, we get 7. And now we divide by 7. Eventually, we get the three numbers to become 1. Therefore, the LCM will be 2 cubed times 3 times 5 times 7, which gives us 840. Now, let's try this example yourself. Find the LCM of 54, 84, and 110. You can pause the video and try to solve it yourself. Here's the solution. For method 1, 54 equals 2 times 3 cubed. 84 equals 2 squared times 3 times 7. And 110 equals 2 times 5 times 11. Therefore, from here, the common bodies are 2, 3, 5, 7, and 11 are uncommon bodies. So the LCM will be 2 squared times 3 cubed times 5 times 7 times 11, which gives us 41,580. We can also use method 2 to find the LCM, which is 54, 84, and 110. All can be divided by 2. We get 27, 42, and 55. And from here, they don't have common divisor. We can just start with 2. So 42 divided by 2, we get 21. The rest is not divisible by 2. We just copy down the value. Now 27, 21, and 55. So we can divide by 3. For 27, we get 9. 21, we get 7. 55, it's not divisible by 3. We just copy down the value. And now we continue with 3. 9 divided by 3, you get 3. The rest, we just copy down the value. Carry on with another 3. So 3 divided by 3, you get 1. So 755 remain the value. Next, we divide by 7. We divide by 5. So we get 1, 7, 11. And now we divide by 7. We get 1, 1, and 11. And finally, we divide by 11. The three numbers becomes 1, 1, and 1. Therefore, the LCM is 2 squared times 3 cubed times 5 times 7 times 11, which gives us 41,580. Now, let's try to solve word problems related to LCM. Here's an example. Two cars drive off from the starting point of a track. Car A takes 60 seconds to complete one lap, while car B takes 75 seconds to complete a lap. Find 1. The time taken for the two cars to be the next round together at the starting point. 2. The time taken for the faster car to be ahead of the other car by 12 laps. Here is a solution. For 1, to find the time when the two cars reaching the starting point together again, we need to find the LCM of the time each of them complete one lap. That is 60 seconds and 75 seconds. So 60 equals 2 square times 3 times 5, and 75 equals 3 times 5 square. The LCM will be 2 square times 3 times 5 square, which gives us 300 seconds. For 2, the time taken for the faster car to be ahead of other car by 12 laps. So first, we need to know the number of laps completed by each car in 30 seconds. For car A, it is 300 divided by 60, which is 5 laps. For car B, it is 300 divided by 75, which is 4 laps. So to illustrate the condition, let's look at the timeline. So this is the timeline for car A. Every 60 seconds, it complete one lap. So the first 60 seconds is lap 1. The next time is 120, lap 2. The next round is 180 seconds, lap 3. And the next time is 240 seconds is lap 4. And finally, at 300 seconds, it is lap 5. For car B, the first lap takes 75 seconds. The next lap, it is at 150 seconds. And the lap number 3, it is at 225 seconds. And finally, at 300 seconds, it completes lap 4. From here, car A is ahead of car B by 1 lap in 300 seconds. Therefore, time taken for car A to be ahead of car B by 12 laps will be equals 300 times 12, which gives us 3,600 seconds. Now you can try this example yourself. In a signaling system, a red light flashes every 20 seconds while a green light flashes every 45 seconds. A bell will ring when both red light and green light flash together. 1. If both red light and green light flash together when the signal system is turned on, how long will it take for both the lights to flash together again? 2. Calculate how many times the bell will ring in an hour. You can pause the video and try to solve it yourself. Here is the solution. Number 1, we need to find the LCM of 20 and 45. So 20 is 2 square times 5, 45 is 3 square times 5. The LCM will be 2 square times 3 square times 5, which gives us 180 seconds. So both the red light and the green light will flash together again after 180 seconds. Number 2, 1 hour equals 60 times 60, which is 3,600 seconds. So 3,600 seconds divided by 180, we get 20, which means that the bell will ring 20 times in an hour. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.